We usually picture European summers as mild and comfortable, but in 2026, waking up in cities across the continent meant stepping out onto scorching streets, with the air hitting you like a blast from a furnace. This chart shows how fast the situation escalated. Over just a few days, temperatures skyrocketed, blowing past the 40 degrees Celsius mark at weather stations across France, Germany, Italy, and Spain. The physical environment simply couldn't handle that kind of thermal stress. Asphalt roads softened under the sun, railway networks ground to a halt to prevent warped tracks, and regional power grids buckled as millions of people simultaneously cranked up their air conditioning. When a hurricane or flood strikes, the danger is obvious. You see the storm clouds gathering, the winds howling, and the structural damage left behind. This emergency was entirely different because the sky remained perfectly clear while the heat mounted. The real tragedy unfolded quietly behind closed doors. Hospitals quickly filled with patients suffering from severe dehydration, respiratory failures, and heat stroke, leading to thousands of excess deaths, particularly among the elderly and those with pre-existing medical conditions. An invisible force effectively turned an entire continent into an oven. To understand how that happened, we have to look up into the upper atmosphere. The culprit behind this crisis was a specific meteorological event called a heat dome. This diagram shows what that looks like in cross-section. It starts when a massive high-pressure system parks itself over a large landmass, creating a heavy column of air pressing downwards. That sinking column acts exactly like an invisible lid on a pot. It forms a rigid boundary, physically trapping warm, circulating air close to the surface, so it has nowhere to go. With that lid secured, solar radiation from the summer sun bakes the trapped air day after day. Because the high pressure prevents the air from rising and venting its heat, the temperature near the ground simply builds. The local climate stops behaving like an open atmosphere and instead turns into a sealed, inescapable pressure cooker. On this map, we see how the European climate normally functions. Cooler weather systems drift freely across the continent, mixing with warmer air and naturally regulating land temperatures. But that massive high-pressure dome physically blocks these relief currents. As cooler, regulating weather systems approach, they hit the rigid boundary of the dome and are deflected entirely around its edges. With all the cool air bypassed, a vicious cycle takes hold. The interior continues to absorb solar heat without any break or atmospheric mixing, forcing the trapped heat to compound and escalate exponentially. Because this deflection loop kept the dome firmly in place, what should have been a standard hot week stretched into a lethal, prolonged emergency. This chart, tracking global baseline temperatures over recent decades, shows a steady upward trend. This rising baseline injects thermal energy, correlating with more frequent, longer-lasting high-pressure systems. The 2026 heat wave is a massive spike on this trend, supercharged by human-driven climate change. The record-breaking heat of 2026 stands as a mathematically predictable consequence of an overheating planet. In the end, the extreme heat claimed thousands of vulnerable lives. It did so silently, leaving behind no flattened buildings or flooded streets, only quiet tragedy in strained hospital wards. The 2026 European disaster serves as a stark, unavoidable preview of the climate challenges awaiting future generations. As global temperatures climb, these types of prolonged atmospheric pressure cookers will become an increasingly common part of summer. The question we face now is whether our power grids, our physical infrastructure, and our healthcare systems are ready to handle the inevitable return of extreme heat. If you found this breakdown insightful, please like, subscribe, and share this video. Let us know in the comments, do you think our cities are prepared to withstand the next severe climate event?